Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we'll be learning about highest common factor and lowest common multiple. So, if you've watched my previous videos on prime factorization and divisibility rules, you'll find that this will help you in understanding what we're about to do today. So, let's start with highest common factor. What is it? Okay, so the word highest common factor simply means we're looking for a number that goes into two numbers and it's the biggest one. So, the word factor we should already know from our previous video. It's a number that goes exactly into another number with no remainders. A common factor would be a number that goes into two given numbers. So any number that goes into 20 and goes into 32 would be a common factor of them both. And there's a long list of numbers that does this, but the highest common factor is simply the largest number that goes into both of these given numbers. So to do this, we can use our prime factorization method to break down the number. So I'll be using the method from the previous video on prime factorization, where we do the bus stop method and work down the page. Okay, so we've broken down the number 20 into 2 times 2 times 5. And the number 32 is 2 multiplied by itself 5 times in a row. Now, you'll notice that I haven't used the powers that I've used in the previous video. Normally, you'd leave the answer as 2 squared times 5 and 2 to the power of 5 if we were simply wanting to break down the number into its prime factors. However, by writing it like this, it'll be more obvious what we're about to do now with highest common factor. And that is, we're going to be using something called a Venn diagram to list the factors of both of these numbers. So a Venn diagram involves two circles containing the factors, in this case, of the two starting numbers we were given. So what do I mean by that? So I'm going to write down a factor of 20 and 32 in the overlap here. So what number is common to both of 20 and 32? That would be this number 2 and this number 2 as well. All the remaining numbers are unique to each separate number. So this number 5 is unique to the 20, so that will go in this section of the Venn diagram. And these 3 factors of the number 2 will go separately into this part of the Venn diagram. So, for the highest common factor, we're looking at the overlap. So we abbreviate highest common factor as HCF, and the result for the highest common factor is both of the 2's in there. So 2 multiplied by 2 is the highest common factor, which is 4. And so we can simply just write down the highest common factor is 4. Now, using this same example, we'll take a look at lowest common multiple. So what does this mean? Well, a multiple is a number in a times table. For example, the multiples of 5 are 1 times 5, which is 5, 2 times 5, which is 10, 3 times 5, which is 15, and so on and so on. Another example, the multiples of 3 are 3, 6, 9, 12. So, what are the multiples of the number 20? Well, that would be 20, 40, 60, 80, and so on. the multiples of 32 would be 32 times 1, 32 times 2, 64, 32 times 3, 96, and so on. So we're looking for a number that is in both of these lists. So you could just keep extending these lists until we come across the lowest or the first number in both of those lists. However, with this Venn diagram, we can also use the list of the factors to help us get that. So how do we do this? Well, we simply multiply all the numbers together inside this Venn diagram. So this number 5, 2, 2, 2, 2, and 2 will multiply together. So the LCM, or the lowest common multiple, is 2 to the power of 5 multiplied by 5. So 2 to the power of 5, 32. 32 multiplied by 5 is 160. And if you'd continued this list, we would find that this would eventually become 160, and this would eventually become 160. Now, how can we answer this question without the Venn diagram? Well, we can look back at these factors when we did the prime factorization, and the highest common factor was what they both shared, but with the lowest common multiple, we're now looking at the numbers that they don't share. So this 32 does not have this number 5. So if you were to give it the number 5, 32 multiplied by 5 is also the lowest common multiple, and the number 20 does not have this factor of 8, which is the 2, 2, and the 2, or the extra 2, 2, 2. So you could multiply the number 20 by 8, and you should also get 160. So that's how you could do it without the Venn diagram. So hopefully, if you've understood what we've just done, we'll do another example. Okay, so here's our next question. We're going to find the highest common factor and the lowest common multiple of the numbers 100 and 270. So these numbers are larger than the previous ones, so perhaps doing a multiplication table or writing the multiples might take too long. So in the interest of time, this is where our prime factorization method will come in handy. Okay, so I've broken down the numbers into their prime factors. 100 is made of 2 squared times 5 squared, and 270 is made from 2 times 3 cubed times 5. So we could do our Venn diagram, and if you still want to do that, this is how we'd list the factors. So in the overlap, this is where we'd write down the numbers that they share. So if I write this in full, and this one in full, we can see that they both share a number 2, and they both share the number 5. So that's what we'll write down in the overlap. Now, the remaining numbers, 2 and 5, will be written in the 100 and the just 100 side, and in the just 270 side, we'll write down the 3 3s. So the highest common factor is 2 times 5, which is 10. And the lowest common multiple is all of these multiplied together, or we can give the 270 the extra 2 times 5, which is 10, or we can give the 100 the extra 3 cubed, which is 27. And notice how both of these result in 2,700, which is the lowest common multiple of both 100 and 270. So let's try one more example. Okay, so for our final example, we'll be taking a look at finding the highest common factor and the lowest common multiple of these two large numbers, 1,960 and 3,430. This might be a typical question found in your non-calculator paper. So I will break down both of the numbers into their prime factors to begin with. So once you've completed the first step of breaking the numbers into their primes, so we have 2 cubed times 5 times 7 squared and 2 times 5 times 7 cubed, we can then compare both of the lists of prime numbers for the highest common factor. So starting with the number 2, there are 3 number 2s in this list and a single number 2 in that list. So the most that we can have from both lists is a single 2. Now with the number 5, there's a single 5 here and a single 5 there. So for that, we can simply write down a single 5. And finally, for the number 7, there are 2 of them here and 3 of them there. So the most that we can have from both lists are 2 7s. That means the highest common factor is 2 multiplied by 5 multiplied by 7 squared. And luckily for us, this is easy to work out. 2 multiplied by 5 is 10 and 7 squared is 49. So 10 multiplied by 49 is 490, the highest common factor. Now for the lowest common multiple, we will look at the remaining numbers. As in, which numbers do 1,960 not have, and which numbers do 3,430 not have. So starting with 1,960, it's lacking this extra 7. Or the 3,430 is lacking the extra 2 squared, which is the number 4. So if you multiply either of those together, you'll get the same result for the lowest common multiple, and that number is 13,720. So hopefully you've managed to follow along. If this video has helped you out, please recommend it to someone who you think it would also benefit. Please leave a comment, like and subscribe if you'd like to see some more of this content, and I will hopefully see you in the next video. Take care.